Hey, what up, girl? How you doing? I don't want to come on.
Most pipelines operate on a cycle of trial and error. You iterate through versions 1 to 5, with each revision ballooning in complexity. Tracking these metrics reveals the hidden damage. Every adjustment pushes the schedule back, and capital burns at an accelerating rate. The chaos of these early stages often obscures the original goal. When teams are scrambling to fix immediate bugs, core project requirements get overlooked, introducing massive operational risk downstream. But consider the math if that cycle never happens. What would a project's economics look like if the product was engineered correctly on the very first attempt? That is the premise of first-time right design. It is a strict discipline built entirely on prevention over correction. By hitting the engineering targets immediately, you eliminate the financial drain of rework at the source. Looking at this blueprint layout, we are at the absolute chronological start of a product's lifecycle. To bypass the iteration loop, quality has to be built into this foundation on day 0, long before any physical materials are ordered. The first input required is the voice of the customer. Engineering teams have to actively extract and isolate the exact expectations of the end user so they know precisely what target they need to hit. We can see that process map out here. The second pillar, requirement management, is the difficult work of translating those abstract, subjective desires through a rigorous filter, turning them into precise, measurable engineering geometry. If a subjective need bypasses that translation filter, the system breaks down. A misunderstood customer expectation inevitably generates unachievable or physically incorrect engineering parameters on the other side. Securing these two inputs without error is the only method for locking in a stable target. It effectively neutralizes the primary cause of foundational redesigns later in the project. With requirements locked, the timeline moves into active execution, where engineers construct the framework around those precise parameters. To maintain that precision, teams rely on the third pillar, design reviews. These are rigid, scheduled checkpoints built directly into the calendar, deployed specifically to hunt for and catch any deviations from the original plan. That search is powered by the fourth pillar, lessons learned. By actively integrating historical project data into the current design phase, teams ensure they never commit the same engineering error twice. When an error slips past the engineering phase and reaches the manufacturing floor, it is called a design escape. Together, historical lessons and rigorous reviews form an interlocking net to trap those escapes while they exist only on paper. This means a first-time right workflow never relies on hoping for accuracy. It systematically filters out deviations step by step, forcefully protecting the downstream assembly timelines. Now we reach the final chronological stage of the design sequence. This is the ultimate barrier standing between the engineering department and the physical manufacturing floor. Looking at this security gate model, we find the fifth pillar, verification and validation. Before any metal is cut, the design must survive these intense testing protocols. Verification proves that the objective, mathematical engineering targets were hit precisely. Validation proves that the subjective voice of the customer was actually honored in the final output. Passing both tests creates an impermeable net. It guarantees that absolutely zero unproven or flawed concepts make it to the physical production stage, where mistakes become incredibly expensive. By sealing the design at this exact point, verification and validation close the loop, proving that the inputs collected on day 0 were flawlessly executed. Here's the visual contrast. The top timeline shows the traditional pipeline, burdened by backtracking. The bottom shows the first-time right approach, moving linearly. Eliminating these loops stabilizes the bottom line, reaching the market months ahead of schedule at a fraction of the cost. And once those products reach the field, the benefits continue to compound. Units designed with this level of rigor demonstrate much higher physical reliability, which translates directly into elevated customer confidence. Implementing this workflow requires a cultural shift. It demands an organizational commitment to front-loaded discipline, prioritizing accuracy over early-stage speed. Excellence is engineered into the project long before the physical assembly begins. By committing to do the right thing at the right time, organizations ensure the finished product is exactly what the customer expected.
Hey, what up, girl? How you doing? I don't want to come on too strong or nothing like that, but